Okay folks, in this lesson we take a look at the conversion, math, and shading state nodes. So if I create a new shader network, we already discussed the AOV and the color node. Then we have this conversion nodes which allow for conversions between data type, and at the time being, most of these conversions are done automatically if necessary by Arnold itself. So these nodes aren't as important as before, but still they can be very useful. So you can see we can convert float to integer, float to matrix, float to RGB, RGB to vector, RGBA to float, vector to RGB. So we have all of these conversions. And we have the down here the math nodes and also the shading states nodes. The shading state nodes allows access to ray and geometric properties such as the surface normal, the UV surface parameters, ray depth, etc. For example, let me connect this probably to our sphere geometry for now and bring in a state vector. And as you can see, now we have different variables. Let's access normal, and let's say I want to control the base color of my standard surface shader with this state vector node in its normal output. And now, okay, there you have it. And we can use different things, maybe a shading point in object space, and as you can see now we get slightly different results. Now if I just set this back to normal, the output of this obviously state vector, as you see from the node, is a vector output, but the base color actually accepts RGB inputs. Now this conversion happens automatically. If it wasn't happening automatically, we actually needed to use a conversion node, and in this case, if I come down to my conversion node, something like a vector to RGB. So we connect the vector output to the input, and now we're having an RGB output that can be connected to an RGB input like the base color. So you're getting the same results, but if it wasn't happening automatically, we actually needed to use this conversion node to make it happen. Okay, now we have our deprecated nodes here. So we have the hair, skin, standard, thin film, and volume collector, and this has been obviously replaced. The hair, now we have the new standard hair. For skin, which is completely deprecated, and you can create realistic skin shader using the standard surface shader. The standard shader has been replaced with the standard surface shader. The thin film shader has been obviously implemented inside the standard surface shader, so this one is not necessary anymore. And the volume collector obviously has been replaced with the standard volume, which we'll discuss it later on. We have displacement nodes that we discussed. We talked about light filters, and then we have this very important math node. As you can see, there are a bunch of them. So using the math nodes, you can do different mathematical operations. And now the first one that is important is the complement, which basically returns the reverse of the input. As you can see, complement or invert. So basically it inverts the input. So let me just control tab, load an image. Let's load this one. Also let me stop this so we can take a look at this preview. So this is Alt WV. This is our image. We can use a complement to simply invert the image, right? The next important node here is the multiply. Let me just, and multiply basically returns input 1 multiplied by input 2. So if I again load another image, let's say this wood texture, and let's say I want to multiply this map on top of our wood texture. Okay, so we connect our wood shader as the first input and our second shader as the second input, and the result would be what you see in the preview. Obviously we can do the same thing, for example using a layer node, but you can do that using this multiply node as well. Next we have this range node here. Let me just make some space. And the range node basically remaps the input from the input mean and input max range to the output mean and output max range. So let's say, so we have this image here, and I can connect it to my range input. And now I can change the range of this image from 0 to 1. Let's say I want to decrease the contrast, so I can say my input mean should be about 0.2 and my output max should be about 0.8. And now effectively we have decreased the contrast of this image. Or I can say change the input from 0 to 1 and the output from 1 to 0, and basically inverting the input image, right? So as you can see, it's a very useful node. And we have this random node as well, which outputs a random color from various types of inputs, and it is useful to do variations of colors or shader properties, for example. So let's say I have a utility shader that we discussed in one of our previous lessons, and let me connect this to this object and to the clock as well. Let's run these, not the backdrop. Okay, let's change the mode to flat and change the color mode to object. And as you can see, different objects are having different colors, but we cannot, for example, randomize or change the seed of this randomization. And that's where we can actually use the random node. So what we can do is to connect the output of the utility to the input of the random node, and in this case, because we are dealing with color, we need to make sure we are connecting our utility output to the color input. Connect the output of the random, let's say, to the Arnold Beauty or the next node in the chain. It can be, for example, the base color FS standard surface shader. And now if you change the input type in the random node to color, you should be able now to use the seed value to actually get different randomization. So that's what the random node is for. Okay folks, so that was a quick overview of the conversion math and shading state nodes. I will see you in the next lesson to talk about some other nodes.